All right, if you haven't already, open up all your browser tabs. We're going to want Tinkercad, Arduino pinout diagram, ATmega 320HP datasheets, and the interrupt vector table. Please make sure you have all of that stuff open. We will get started with a quick review of what we did last time. And then we are going to talk about a new type of interrupt today. Okay, give everybody a second to get all your tabs open. Again, if you're just joining us, Tinkercad, all the stuff on Canvas, Arduino Uno pinout diagram, ATmega datasheets, interrupt vector table. All right, okay. There we go. All right, quick review of what we did last time. We introduced something called an interrupt. Okay, so before that we were doing polling, where we wanted to check if a button was being pressed, and we were just using an if-else statement in this infinite while loop here to check when that button was pressed each time this loop ran. The problem with doing that is if there's a lot of code in that loop and it takes a while to run, or there's some delays in that loop, you could miss a button press. Okay, not the end of the world when you're blinking an LED, but if you have a robot driving around or an autonomous car that needs to hit the brakes and not crash into something, right? You can't really afford to wait for that delay. Okay, so we introduced the interrupt service routine, which is a separate function that can, as the name implies, interrupt the main program. Okay, so when the condition for the interrupt is triggered, there are different kinds of interrupts. Then it will jump out or exit wherever it is in the main program, run up to the interrupt service routine, do whatever code is in here, and then go back to wherever it left the main program. Okay, so you can see that if I run this code, I click and hold the button down, the LEDs stay on. Same thing we were doing with polling. The difference is if I add a big delay here, then it'll still work. Okay, that's what we did last time. We have a little more breathing room today, so I'm going to talk about something that I wanted to talk about this week, but didn't have time because we had to get to everything so fast. The whole ChatGPT part of the homework. Okay, ChatGPT did not exist yet the last time I taught this class, so this is the first time I have tried this. I actually don't know how it's going to go. We're going to have a poll about it in a minute to kind of gauge how things are going for people who have tried it so far. My experience when I have tried it, I have not actually sat down and tried to do every single homework problem, but I tried some of the initial ones, is that ChatGPT is very good at spitting out code that looks believable, but does not do exactly what, somebody's using a banana as a phone. I just looked out and saw that. Like, okay, I'm not even going to ask.
They're calling me.
Okay. Okay. Okay, bananas notwithstanding, my experience with ChatGPT is that it's good at spitting out something that looks believable. Okay, you glance at it, you're like, yeah, it looks like it did the stuff I asked it to do. And then when you try to actually run it, it doesn't work. And there is a little thing, like I tried it and it would use, DDRB instead of DDRB, or I would tell it that the button had a pull down resistor and it would write code assuming the button had a pull up resistor. So a lot of the structure is there, but I found that you then may wind up spending more time weeding through and finding what ChatGPT got wrong than if you had just written it yourself to begin with. The other factor to consider is that most of again, there are people at Cornell who can explain large language models way better than I can, right, over in the computer science department. Most of the training data on the internet is the regular Arduino language that you're not allowed to use for this class. Okay, so the register stuff is out there, but there's nowhere near as much of it. So it's also not really trained on as much of this. And kind of thinking as an engineer, I'm not going to take a hardline approach and say, oh, ChatGPT is banned, right? Because before ChatGPT, people would Google stuff and copy and paste things from Stack Exchange threads, right? Like the internet still existed the last time I taught. The risk in either case as an engineer is you don't want to use those tools as a crutch, right? You want to make sure you still have an understanding of what's going on, because I think despite, if you're from, I think when Olaf from ASML was here, he showed that graph of the hype cycle, right, where things get overhyped and, oh, ChatGPT can pass the bar exam and it's going to be replacing people's jobs. And so far, I know 0 people who have lost their job to ChatGPT, right? Maybe check back in 10 or 20 years, but as of this semester, it is not going to replace you when it comes to writing the code for your robot. okay? When it comes to looking up information, just like with equations, I don't care where you do that, right? You need to Google the equation for a capacitor. You need to look up, you don't remember how to do an if-else statement in C, right? You can look that up on Canvas, you can Google it, you can ask ChatGPT. Those lines are blurred now anyway, now that Google integrates AI into the search results, right? I don't care where you look that up. I care if you try to lean on ChatGPT as a crutch to write your programs for you for the labs and the final competition. Both because I want you to understand what's going on and not just try and offload that to AI, and because I don't think it's going to work very well, right? You're going to wind up giving yourself more of a headache untangling what ChatGPT did, because remember, it is just, again, there are people who can explain this way better than I can, it's just predictive text, right? It has no underlying understanding of what registers are or what the hardware connections to the pins are, right? So we are going to actually launch a poll in a second, because I'm kind of curious how this experience has gone for you guys, for those of you who have started the homework. Guys, remember, if I can hear you talking up here, you're being way too loud. Let's keep it down. Poll is launched. For those of you who have started the homework, there's no right or wrong answer to this one. Okay, answer E could just be, I didn't start the homework yet. Remember, if you, a couple of people have asked about this, this is the last homework, so if you have slip days left, you might as well use them anyway. There's no slip day refund policy where you like get extra credit for not using them or something. So if you didn't start the homework and you haven't used, or you still have at least 2 slip days left, you can submit it tomorrow or Sunday late with no penalty. I am curious, for those of you who have tried the ChatGPT part, if your experience kind of matches up with mine, or if it's way different, if you're like, oh no, it was a slam dunk and it worked perfectly on the first try, or it was a total disaster and didn't work at all. So this is, again, just kind of for my sake, because I have not tried this homework assignment before. So if you're just getting here, poll everywhere is up. Give it maybe another 30 seconds for people to get settled and answer that. Okay, we're at 90 replies. Let's do like another 15 seconds. Maybe 10. Okay, I am going to leave this open because again I feel this way. I saw a couple people just got here, but I'm going to switch over so I can see the responses. And actually, I usually don't share these, but I'm going to share this one. Okay, how successful was ChatGPT at doing the homework? Okay, so that's maybe shifted a little more successful than I would have expected for getting it totally right on the first try with no errors. But again, if you think in terms of the training data and complexity of the code, these are all very simple examples. Like pretty much every Arduino tutorial on the internet starts with blinking an LED and then controlling an LED with a button. So as you build up to a more complex robot with multiple sensors, H-bridges and controlling the motors, and some kind of higher level algorithm or strategy, my expectation is that this graph would kind of shift down, right? Like it's not going to do your robot for you. And maybe the bits and pieces, okay, the code for the color sensor, code for the ultrasonic sensor. I would be shocked if the team that has a winning strategy for the competition kind of used ChatGPT to come up with all their code. Okay, and again, if you're in the roughly half of the class that hasn't started yet, that is okay. Use your slip days if you have them remaining. All right, I'm going to close that one. I'm going to activate the next one, but I actually just said the answer to this a minute ago, so do not respond to this one. Okay, going to activate. The question here was, when does an interrupt service routine run? So even though the interrupt service routine is up there at the top of the program, it does not run before the main function, right? Your program still starts with the main function, does the stuff in the main function, goes into the while loop, and the interrupt service routine will be called even if you're in the middle of the while loop, okay? It doesn't wait for an iteration of the while loop to run. If there were 10 lines of code in there and the condition gets triggered while this is on line 3, it'll jump up there and back down. So again, do not answer this one. If you're in the room, delete your answer. Okay, see the number just went down. If you're in the room, do not answer this poll. I'm going to give you 10 seconds to delete your answer if you just did. Okay, 5, 4, 3, 2, it just went back up. If you're in here, delete it. 3, 2, somebody's confused. No, don't text your friends who weren't here that this is a sting question. Last chance. Okay, actual 5, 4, 3, 2, 1. Deactivate. Okay. Next question I do want you to answer. This is a reminder about what we did last time. An external interrupt can trigger only on a rising edge, only on a falling edge, or on either a rising or a falling edge.
Is it up?
I just hit activate. It should be. Is it up? Okay. Yep. Right. This one should be pretty quick, so let's just give that like another 20 seconds, please. Okay, 15, 10, 5, 4, 3, 2, 1, deactivate. Correct answer there, good. 93% of you got that right. It can trigger on either a rising or a falling edge. I should have written or both there. Okay, so you can select whether it triggers on the rising edge or the falling edge or both, which is going to lead us to today's lecture. There is another kind of interrupt called a pin change interrupt. So if we go to the Arduino Uno pinout diagram, I'm going to maximize this. There's all this gray column of labels here that say PC int and then a number. Okay? PC int stands for pin change interrupt. So remember, for the external interrupts, and I don't know who exactly came up with the naming conventions because conceptually these things are very similar. The external interrupts, int0 and int1, are only available on pins 2 and pins 3. Those are the ones that let you select either rising or falling edge or both. And they each have their own interrupt service routine. There is one interrupt service routine per pin. The pin change interrupts, as you can see, are available on pretty much every pin, but they always trigger on both a rising and falling edge. Okay, you can't select which one you want. And there are only 3 interrupt service routines, or functions that will get called. Okay, so there is an interrupt service routine basically for each port. Okay, so port D here, there's only one interrupt service routine. So if I connected 2 buttons here, say to 2 different pins, say PC int 20 and PC int 21, and set up the interrupt for those buttons, they would both call the same interrupt service routine. I can't have different functions for them. I could then use an if statement inside the interrupt service routine to detect which button was pressed. Okay, but I don't have, whatever, 20 different interrupt service routines. So that, everything I just said is in the slides from last time, so there isn't going to be a separate slide deck for today, but the notes about the differences between external interrupts and pin change interrupts and how many interrupt service routines and all that there are, that is all in the slides from last time. Okay, I'm not going to show them again today. We're just going to go through a Tinkercad example of setting one of these up. So I want you should have a handful of Tinkercad circuits at this time. Make a copy of something, I don't really care which one, okay, and call it pin change interrupt, so you have this code because you are going to need this for lab 4, actually, so we're a little ahead now. That reminds me of the things I forgot. Things I forgot to announce. Lab 3 is next week, okay, that has a pre-lab assignment that has all been on campus for a while. And TA evaluations are still live. I thought they had closed those, but apparently they are still up. So especially now that you've maybe had a little more time to interact with the TAs in office hours and labs and everything, if you have something nice to say about one of the TAs, I'm sure they'd appreciate it. If you have constructive criticism or something you think I should know in terms of how you've interacted with one of the TAs, I would appreciate that as well. So I know you guys get a million emails and surveys, but that one is still up if you can dig back and find it. Core staff would appreciate it. Okay, pin change interrupts. We're going to need, again, for lab 4 and then the robot. Okay, so I want you to, same circuit, except in this case, I do want you to pick different pins than what I've used. So I'm going to use pin 7 for my LED and pin 12 for my button. Pick 2 different pins to kind of force you to go through this process yourself and look up stuff in the data sheet as opposed to just copying exactly what I'm doing. And start with just a skeleton of the code. Okay, I want you to kind of get used to, rather than copying and pasting the same code each time, kind of doing this from scratch again. So we have a blank interrupt service routine that we're going to fill in, and then we have a blank main function with a while one loop. Okay? Give everybody a couple minutes to get that set up. And then we are going to set up a pin change interrupt to do pretty much the same thing we did last time, but with, again, different registers, different interrupt service routine. Our goal is going to be to just turn the LED on while the button is held down, turn the LED off when we release the button. All right. Step 1, okay, you're going to look at whatever pin you connected your button to. Okay? Go to the Arduino Uno pinout diagram and look up which PC int corresponds to that pin. Okay, so in my case, I have my button on Arduino pin 12. And if I look here, Arduino pin 12 is PC int 4. Okay, again, that is for me. I want you to pick a different pin. Okay, so I'm going to put that in a comment in my code. Remember, this is code that only runs once when program starts. Need to enable PC int 4. Okay, you're going to have a different number there depending on which pin you connected it to. Okay, and I'll give that, we have a little more breathing room today, so we'll try to go a little slower, make sure everybody has time to catch up. Questions so far? Or trouble, like where to find the information or anything? All right, next, you are going to go to the AtMega datasheet, page, I believe it's 92. Let's see if I can get the page numbers to cooperate with me this time. There we go. We're actually going to scroll down to page 94. Okay? So there are 3 different, I'm going to maximize this for a minute. Come on. There we go. Okay. I have 3 different registers here. Pin change mask register 2, pin change mask register 1, and pin change mask register 0. Okay, and we see that in these registers, there are individual bits with names corresponding to the Arduino pins. Okay, so PC int 23 all the way down to PC int 0. Okay, so the names of those bits correspond to these names in the pin diagram. Okay, so you need to find the bit that corresponds to the name you wrote down. So I need to go find PC int 4 in the data sheet. Okay, so for me, that one is here. It's the 4th bit in pin change mask register 0, which is PCMSK 0. Okay, so to enable the pin change interrupt on that pin, I need to set that bit to 1. I'm only using one button. I don't care about all the other ones. I'm just going to leave them as 0. okay? Again, you are going to have a different pin and a different PC int something, okay? So remember that. You already have the comment for it in your code. Okay, so I'm going to need to set, maybe kind of do this one at a time. PC MSK0 is the register I'm going to need, right? You might need a different register if you picked PC int 12, then you're going to need PC MSK1, okay? The register that corresponds to the bit or pin you have. So I'm going to set PC MSK0 to something, okay? And again, for me, I need to set this bit high. So I'm going to choose to use bit shifting this time. I'm going to do 1 left shift 4. And again, remember that's equivalent to writing PC MSK0 equals 0B 7 6 5 1 1 2 3 4. Okay. Same as doing that. I'm just setting that single bit high. Those two lines of code are equivalent. Okay? Okay, so do that for the bit you selected. Yes?
Bit 2, would it be 1 left shift 2?
Yes. Because remember, the registers start counting, the rightmost bit is bit 0. So if you just wrote equals 1, then that's like setting this bit to 1. If you did 1 left shift 1, that's setting this bit to 1, and so on. The other trick I haven't mentioned yet is that you can also use the name. I wrote this on the whiteboard in the lab, but forgot to mention it in lecture. They're kind of, I think macro might be the right word, that stores the place of the bit in a variable that has the same name as the bit. So you can also do this. I could write left shift PC int 4, and the Arduino knows that PC int 4 is just a variable that has the value of 4 corresponding to the place in the register. So if you don't even want to count which bit it is, you can also look up the names of the bits and use the shift operator with the name of the bit. Okay, and that is, so 3 different ways to do the same thing. I'm going to stick with the left shift 4 for now. You do have to be careful with that. If you're individually writing to multiple bits, say if I was going to turn another one on after that, I would need to use masking. As for example, if I just did this is a bit of a tangent. If I wanted to turn 2 different interrupts on, say I also had one on bit 5, if I just did this, then this second line is going to overwrite that first line and turn 4 off. That is the equivalent of having another line right after this one, and I think some people made this mistake in some of the earlier lectures. If I just do that, okay, so forget the bit shifting lines for a second. If I just do this, then this second line overwrites that first line, okay? And I've turned this one off again. So I could, if I'm writing out the whole register, I just do that all in one line, right? I do that and make both of them 1. Or if I'm using bit shifting, I use masking with these, the bitwise OR operator, and that only sets each one of those bits high without accidentally setting all the other ones to 0. So like 3 different ways to ultimately do the same thing there. I'm going to delete most of that because for now I'm only turning the 1 on. All right. Okay, so whatever your personal preference is, especially if you learned it in another class or something, whichever method you want to use, same way to do the same thing. All right. Questions? I hear a lot of chatter. People figuring it out. Suck. Good? Okay. I'm not done yet. There is another register I need to enable. So if I go back to the data sheet and scroll back up, okay, I have the pin change interrupt control register. Okay, this one only has 3 bits in it. PCIe2, PC. Guys, if you're stuck, let me know. I don't want to keep going if I'm going too fast. I hear a lot of like, anyone stuck? Need more time? You gotta give me something. Okay, good. I'm seeing thumbs up, so I'm assuming we're good. All right. There are 3 bits here corresponding to the 3 interrupt service routines. Remember, even though there's 20-something pins, there's only 3 corresponding interrupt service routines. So you need to enable the one of these that corresponds to the port you're using. So for example, for me, my bit or my pin is in PC MSK 0, pin change mask register 0, which corresponds to PCInt 0. So PCInt 0 through PCInt 7. If I look at the pinout diagram, that's here, right? PCInt 0, and actually it only goes up to PCInt 5 here, and then I think 6 and 7 are somewhere else in the diagram. But point being, this is on pin change mask register 0. So in this register, I need to set that bit, PCI 0 to 1. Okay, if you happen to pick a different pin, say you picked PCInt 22, which is part of PCMSK2, then you would set, I just scrolled too far. You would, no, not that one, there we go. You would set PCIe 2 to 1. Okay, so there's only 3 interrupt service routines, depending on which bank of pins or which port you picked, you set one of these to 1. So I'm going to do PCICR. Again, in my case, I'm setting this one to 1. You might be doing one of the other ones, depending on which pin you picked. Equals 0B, 1, 2, 3, 4, 5, 6, 7, 1. Okay, or you could just write equals 1 if you don't want to write out all the other zeros. Same thing. Okay, so and I should be doing it better. So this enables PCInt 4, and this one enables pin change interrupt 0. Now note that the terminology gets a little confusing because a 0 here, 0, 1, and 2 here do not correspond to 0, 1, and 2 here. That's where it gets a little confusing. It's clearer for the bigger numbers, right? If I pick PCInt 23, then that is clearly part of pin change mask register 2, right? But the 0, 1, and 2 are kind of confusing. So 0, 1, and 2, PCInt 0, PCInt 1, and PCInt 2 are all part of pin change mask register 0. So don't get the 0, 1, and 2 mixed up. Okay? Okay, so we've enabled the pin change interrupt on this pin, whichever one you selected. For that to work at all, we still need to enable interrupts globally, so we still need that SEI command. Okay? And then we also need to put the correct vector in our interrupt service routine, right? The interrupt service routine is blank so far. We need to make sure that the interrupt service routine actually gets called. To do that, we go over to the interrupt vector table, which again you should have open as linked in Canvas, and look up the vector name for the pin change interrupt request you picked. Okay, that's either going to be 0, 1, or 2. So for me, that is PCInt 0 vect. For you, it might be different. Okay? So in here, I'm going to fill in PCInt 0 underscore lowercase vect. Okay. Everyone with me so far? Any more time? Yes.
Sorry, how did you find the PCInt 0 vector?
That is in a document called the interrupt vector table on Canvas. So in the same section as the Arduino pinout diagram in the datasheet. Okay? And then there are 3 rows here for pin change interrupt requests 0, 1, and 2, corresponding to the 3 options you could have picked, and then you just get the name from the right-hand column here. So mine is PCInt 0 vect.
Why is it 0?
Because of the pin I picked. Okay, so I have my button on pin 12, right, which the individual pin is PCInt 4. Okay, if I go to the datasheet, PCInt 4 is part of pin change mask register 0. That's where I got the 0. So depending on And if you picked PCInt 12 for the individual pin, then you would be using pin change mask register 1 and interrupt 1. Okay? Okay. So I have everything set up, but my code's not doing anything yet. So if I click the button, nothing's going to happen. To make sure my interrupt is working, I'm going to do serial print. Oh, sorry. So serial begin 9600. And then inside my ISR, I'm going to put a serial print ln, I don't know, interrupt triggered, or whatever message I want to put there. Okay? And I run that. My LED is not doing anything yet. But I should be able to run that, open serial monitor. And now remember, with the external interrupt we did last time, I selected whether I wanted rising edge, falling edge, or both. Here I always get both. There is no choice. Okay, so I'm holding my mouse button down right now. I just clicked the button once. It only printed interrupt triggered once. When I release the button, it triggers the interrupt again because I get a falling edge. Okay, so I can just keep clicking. Every time I click, rising edge, interrupt triggered. Every time I release, falling edge, interrupt triggered again. Okay, I want you guys to add the code to control the LED. Okay, so I didn't fill in the DDR port registers here, but you should get comfortable doing that from scratch because again, you're going to need at least 4 of those for controlling the H-bridge for your robot. Okay, so add code to control the LED to make it do the same thing we did before. When the button is held down, the LED should be on. When you release the button, the LED should turn off. Okay? If you don't remember how to do that, try asking someone near you first. If you are totally stuck, then raise your hand and ask me. But I want you guys, again, you're going to be working in groups for the final project, so I kind of want you to get used to working with each other on this. No, you haven't added anything to control the yet. I want you to try. LED should be on when the button is clicked and held down, off when the button is released.
What tells my button to oh, great.
Okay, with the 12 minutes we have left, even if you're not quite done with your LED, I want to do a couple more things. So, I'm going to toss in the LED code real quick. So again, you need your data direction register. So I'm going to have DDRD equals, for me, I have my LED on pin 7, so that's 1, 7. Setting my LED pin as output. And then inside my interrupt service routine, and there's more than one way you could do this, but I'm going to use my port register to do a bitwise XOR operation just to toggle 5, 6, 7, that bit. So now when I run the simulation, I press the button, and nothing happens because I did something wrong. What did I do wrong? Is that not enough? 7s, that's not enough zeros. Let's do. So this is why bit shifting. Get better. 1 less shift 7. There we go. Okay. So I push once, rising edge, interrupt is triggered. That bit, which was initially off, is flipped on. LED turns on. Release. Interrupt triggered again. That bit, which was on, turns off. Okay. Same behavior we've seen before. Question, what if I want to do something only on a rising edge? Okay, I only have 2 external interrupts, which are the ones that let me select rising or falling edge. Can I somehow use a pin change interrupt to only detect a rising edge? And the answer is yes, with an if statement. So I can put an if statement in here. Just like we did with polling to check the state of a button. So I can do if, in my case, this is going to be, if I check the data sheet, okay, that's port B4, port B bit 4. So I can check if that bit is high, and then have an if-else statement to do different things depending on whether it's a rising edge or a falling edge. Okay, so I can do if pin B and 1 left shift 4. Okay, that's checking. It's the same as writing out 0B 7 6 5 4 3, 2, 1, 0. Okay, that's checking if only that bit is high. So this bit would be different for you depending on where your button is. Okay, and I'm going to set up the structure for my if-else statement. Else. Say I'm going to fill in, rather than just printing interrupt triggered, I'm just going to put in, say, serial.println, rising edge, button pushed. And falling edge for button released. Now, unless I screwed that up, when I run this, I should still get the LED. Clear down here so this is a little easier to see. There we go. LED will still turn on when I push. Right, I didn't change my port D line there, but the if-else statement is detecting whether the button was pushed or released. Okay, so rising edge button pushed, release, bless you, falling edge button released. Okay, so even though I don't have the same functionality as the external interrupt, where I can make the interrupt only trigger in one of those conditions, I can still detect which condition it was using an if-else statement. Okay, I'm pretty sure you're going to have to do that for lab 4. Okay, and we're running a little low on time, so I just went through that myself instead of having you guys figure it out. Okay, questions on how that works? Everyone believe me? Okay, with the 5-ish minutes we have remaining, then the last thing we are going to talk about that we haven't really talked about yet, you might notice this is maybe a little weird, we haven't really talked about variables yet, right? We've talked about registers and writing values to these registers, but we haven't just had X or some variable in code. So in a C program, and I believe this is different from both MATLAB and Python, you need to declare a variable before you use it. Okay, you can't just have a line down in your code somewhere that says x equals 2 or x equals x plus 1 or whatever. At the top of your program, you need to both declare the variable and tell C what type of variable it's going to be. So I do not have a slide or a table prepared on this, but the Arduino is not a computer. It has very limited memory, and there are different types of variables that require a different amount of memory to store. So like the difference between an 8-bit integer that can only go up to a value of 255 versus a 16-bit integer. And then there's floating point variables that can have a decimal place. So in general rule of thumb, you want to use kind of the smaller variable that doesn't take any more memory than you need. So most of what we do, an integer is fine. So you write int to tell it that the variable is going to be an integer, and then the name of whatever the variable is. You don't have to give it an initial value. You can just declare it like this, okay? Or you could give it some initial value and say int x equals 0. Okay, so if it is declared up here outside of any functions, is a global variable that I can then use anywhere in my program. The programs we are writing in this class are simple enough that you can usually get away with that. Okay, there's a whole different discussion about whether using global variables is bad and you're better off using local variables. I don't really know what was taught in the intro CS courses here, but you can also declare variables inside a function and then it's local to that function. Not going to get into that too much right now. If you have a personal preference, you work or have been taught that one way is better than the other, it works either way. You're not going to lose any points in this class for using global variables. Okay. So, point being, I have it there. Integer means it cannot have a decimal place. Okay, so if I try to write x equals 3.5, it's just going to truncate the 0.5. Okay, this variable type does not store decimal values. Okay, and then if I want to do something with that variable somewhere, say I want to increment it just every time the interrupt is triggered. I just want to increase x by 1, right? I can just do x equals x plus 1 just like you would in any other language. Okay, and then I can do say serial, oops. Like that, and I can print out the value of the variable of the serial monitor, which is going to be useful for debugging. And as you go for, especially for lab 4, you're going to be asked to print out the value of a period, where we're measuring the period of a square wave, which you can hook up and measure with an oscilloscope. Right? So ideally, if you measure it with an oscilloscope and you measure it with an Arduino, you should get the same period. Okay? But you can't see the period unless you print it out. Okay, so if I open my serial monitor again, clear that, and start simulation. Now ideally, okay, I have a variable counting up each time the interrupt is triggered, so I'm keeping track of the total number of times I've clicked and released the button. Say if I only wanted to count how many times the button has been pressed, then I can move my x equals x plus 1 in here, so it's only with the rising edge, right? And then if I clear and run this again, now see it's still 1 when I release, right? So now I'm just counting the number of times I've clicked the button. Okay? So that is your crash course in how variables work in C. Again, I actually don't have my own Canvas resource for it, but if you just Google variable types, or I forget if the programming syntax reference in Canvas actually has a section on this, but if you Google that, you'll see a table with the different variable types, how much memory they take, and the range of values they can store. So you can store integers that can be positive or negative, integers that can only be positive, and again, there's the floating point ones that can handle decimals and all that. You're going to need to do that in lab 4. You can do it on the homework for the problems that ask you to change the LED behavior so the LED stays on when you release the button. Okay, there's different ways to do that, but one way is to store a state variable for whether the LED is on or off, and then each time you push the button, you check, okay, well, what was my last state, right? If the LED is already on, I'm going to turn it off. If the LED is already off, I'm going to turn it on. You don't have to use variables to do that, but that's one way to do it. And then again, when you get to your robot, if you want to have, this is going to get a little more complicated, we'll talk about it more after spring break, some strategy that is keeping track of the state of the board. So is the other robot in front of me? How far away is the other robot? Am I on a border? Which color am I on? You may want to use variables to keep track of all that stuff. So you, I think, can get away with actually doing this homework without using any variables at all. But again, you're going to need it for lab 4 and probably for the competition. Okay. We have 2 minutes left, but it's really nice out. So as usual, I will be here after class if you have questions. And office hours are open in lab today if you're still working on the homework. Thank you.